Hi everyone, my name is Benjamin, and in this video we will cover some Solana basics to get you started building on Solana. So we will discuss what Solana is and what type of applications it typically runs, how a blockchain and Solana works, what dApps are and how you can build on Solana by using and consuming RPC nodes and its services. We will also look at some commonly used RPC methods, and eventually we are going to buy our own RPC node via the Solana Vibe Station cloud platform. Now, this video is part of a series, so make sure to subscribe so you don't miss any of the upcoming videos where we will eventually build our own trading bot. So, with that said, let's get started. Alright, so before we jump into the fun stuff, let's start with covering some basics. So, what is Solana? Solana is a high-performance blockchain, so a network designed for fast, secure, and low-cost digital transactions. It supports thousands of applications, and we will look at some later on, including payment systems, games, digital art platforms for NFTs, and also financial services. So you can send money globally, create digital assets like, for example, tokens, and that is something what we will do later on, collect NFTs, and you can even play games, join restricted communities, and vote within these communities. All of that you can do on the Solana blockchain. So what is a blockchain? A blockchain is a decentralized, immutable, and shared digital ledger used to record transactions across a network. So let's break that down. So a ledger is a place where transactions are recorded when you send and receive money. So let's say that I sent $10 to my friend and I write it down on a notepad, and my friend also writes down that he received these $10. Now these two notepads, they say the same thing, and they are actually kind of a ledger. It's a place where we record these transactions. Shared means that everyone can see all the transactions, so if our third friend comes by, he can look at our two notepads and he can witness these transactions that happened. And on the blockchain, of course, we have things like SolScan, where we can enter signatures, transaction IDs, token IDs, all these kind of things we can enter and we can really see what happened. Immutable means that once a transaction is confirmed, that it cannot be undone. No one can change it. And decentralized, it means instead of being stored in one place, it is stored within different networks, in multiple places, across different computers. And it also means that you don't have to trust third parties, like for example, a bank. You can trust the blockchain and don't have to think about waiting times and bank fees. So, besides that, it's really hard to hack a blockchain because it uses things like cryptography and algorithms of consensus to make blockchains secure. So in short, you can pay for your coffee securely without any fees and intermediaries. Alright, let's move on. So now that we know what a blockchain is, the next question is, how does it work? And of course, blockchain is an advanced topic, but in a nutshell, a blockchain is just a chain of blocks. Okay, but what does that mean? Let's look at an example. So we have this overview here, and here you can see all these blocks, the chain of blocks, and each block has a timestamp, and of course it has transaction data, but it's not limited to only transaction data, and it also has a hash, and that hash is the hash from the previous parent block. As you can see here, once a block is validated, once it is approved, it is also hashed, and that hash is carried over into the child block. So the child block holds the hash from the parent block. And again here, the same with this block. Once it is approved, once it is validated, it is hashed, and that hash is part of the next block. And that is how these blocks know for certain that the block before is correct, because it holds the hash from the block before. And that is also part of the security where the blockchain is secure, because it is untamperable, as we talked about before. So again, this is a really nutshell explanation, but I believe it is enough for now to move on to start building on Solana. So the next question to ask is, what makes Solana so different? And I believe a better question to ask is, what makes Solana so great? So first of all, Solana is really fast. If you think about traditional banking transfers, which can take up to days, and if you even pay with a credit card, it goes quicker, but the settlement itself takes often longer. Solana handles transactions in under 1 second, which allows us to build real-time applications. And not only that, sending money internationally goes as fast as sending a text. So the speed allows us to trade on the Solana blockchain without having to wait for long confirmation times. Besides that, Solana is also quite cheap, averaging around 4,000 transactions for $1, which means that you pay typically around $0.0025 per transaction, which makes it ideal for high frequency trading and tipping creators. On top of that, Solana also scales really well. It can handle thousands of transactions per second, making sure it runs smooth at peak and quiet periods. And as we discussed earlier, Solana is accessible for everyone. It doesn't matter if you are in a rural area or in a major city, it will provide financial services for everyone around the globe. But how is this different from Bitcoin, for example? Well, Bitcoin is pioneered to be a digital currency, and Solana enables complex applications with much faster speed and lower costs. Think of Bitcoin as a digital gold and Solana as a platform for building applications. Where Bitcoin excels at being a store of value, Solana optimizes the speed and functionality. Many use both for different purposes, but on Solana we can run programs using dApps. So what are dApps? dApp stands for Decentralized Application, and a dApp is an app that uses smart contracts. So any crypto program like a marketplace, a blockchain game, or a tool used for governance, it can be a dApp. So dApps are the tools that we use to do things on the blockchain, whether that's buying some art, voting in your favorite organization, paying without intermediaries, or participating in decentralized finance. Of course, there are rules, and that's why we have smart contracts. So smart contracts are written in the code of the blockchain and executed automatically when the terms are met. It's something that Solana and certain other protocols can do, but some other blockchains like Bitcoin are not that advanced at it. So why and how should we develop on Solana? Now, Solana has a few advantages. It is of course widespread, it's mainstream because of all its perks, but it's also really energy efficient, lightning fast, and extremely inexpensive. And if you want to know more about that, you can always go to climate.solana.com, where you can explore more about the network's sustainability, where they talk about the energy consumption, the carbon footprint. They do some nice comparisons. There are world maps there and also some historical data. So if you want to know more about that, go to climate.solana.com. As we talked about, it's really fast, 1 second compared to 10 seconds for other protocols, and also really cheap transactions, less than a cent as we saw compared to hundreds of dollars for other protocols. And it's really easy to develop, as we have stuff like Rust, we have JavaScript, TypeScript, Python. All these things are available to develop on Solana compared to, for example, Solidity for Ethereum. Now, there are two main ways that you can develop on Solana. You can or create Solana programs, which are dApps that we discussed earlier, and creating programs that run on the Solana blockchain, for example, using Rust or Anchor framework, are often called dApps. Now, we can also create client applications, and these are sometimes also called dApps, but there we will consume the blockchain as a client. So we will interact with the Solana blockchain using tools like Web3.js for JavaScript, for TypeScript, or Python. So that's where we really start working as a Web3 developer, trying to decentralize the web, where everything is built around the idea of decentralization. So instead of the internet being dominated by big platforms, Web3 envisions a decentralized network where everyone can contribute and participate in control. So it's a world that can be built on a blockchain using smart contracts. Alright, so now that we can use a high-performance network, which is secure and decentralized, we can build Web3 dApps, for example, transferring money, NFTs, finance, lending money, voting, gaming, supply chain, it doesn't matter. We can build dApps for all of these things. And how do we do that? By connecting to the Solana blockchain via nodes. So what are these nodes and how do we connect to them? So a node is a server that runs a software that helps run the Solana network. So as a node, you can run that software and have the option to be a voting/consensus node, or you can choose to be an RPC node. And an RPC node helps us devs to talk and interact with the blockchain. But for performance reasons, RPC nodes, they will not vote. You will have a validator node that uses the proof of stake consensus mechanism, and that is because users can stake their Solana to a validator of choice, and the more stake a validator has, the more weight the validator's vote will have in creating new blocks, in validating new blocks for the Solana blockchain. However, we are interested in the RPC nodes, and RPC nodes run the same software as a validator, but it does not participate in the consensus process. Technically, you could run an RPC node and allow that node to also vote as a consensus node, but it's strongly discouraged because that node will not be performant enough to do both tasks really well. As a node that runs RPC, you have a much different purpose, and often you will just reply to requests from users about the blockchain, and you will also allow users of that RPC node to submit new transactions to be included in the blocks in the blockchain. So that is what we are interested in, and if we are going to build these Web3 apps and these trading bots, I think it's the right time now to start familiarizing us with these RPC methods that we can use to consume and talk to these RPC nodes. Alright, so before we are going to order our own RPC endpoint via the Solana Vibe Station cloud platform, I think it's the right time to highlight that there is a ton of information available via the Solana official documentation, where they talk how you can install all the different ways to develop on Solana. You can find info there how you can actually set up Rust, how you can actually set up Anchor, but also how to actually configure the CLI for Solana. Because for that, for example, if you run Windows, you will need the Linux subsystem for Windows. So all this kind of information you can find on the Solana documentation. Now, there's also information about the different SDKs that we can use, like for example, the Python SDK and the SDK that we're interested in, the TypeScript SDK, to interact with the Solana blockchain. So if you would look at the TypeScript SDK, here is all the information on how we can get started, how we can set it up, and all the comments that are needed, all the imports that we need to do to set up our own environment to start developing using these SDKs on Solana. Now, besides the official documentation, there is also the Solana cookbook, and that is also a ton of information if you want live examples on how to do things. And for example, if you go to the Solana cookbook, if you scroll down a bit, you will see examples on how to set up a local validator. There is wallet management on how to create key pairs. There is transaction operations, account management operations, but also token operations. And for example, here you can see on how to create a token, how to get the token mint, how to create a token account. All these different actions that you can do by using these SDKs, they have examples for it. So if you would, for example, click on how to create a token, you will see that they have code examples for you available here and what packages you can use to do so. So if you would look at another example, for example, how to get the token mint, this is a smaller example, but it will also allow you to see how you can do that by using these different packages and using these different methods. Now, the main thing that you need to understand is that you will always need some kind of RPC talk to the blockchain, to interact with the blockchain, to get information, but to also send information to the Solana blockchain. And they have a default endpoint that you can use called API mainnet beta, but these endpoints are often rate limited. A lot of people are using these when you're going to actually build something that needs speed and actually a decent RPC. That is the moment that we need a RPC, for example, from Solana Vibe Station, and that is why we will get one, order one via their cloud platform, and see how we can interact with all these different packages, all these different methods, and eventually build our own trading bot. With that said, let's go to the Solana Vibe Station cloud platform and order our own RPC endpoint. Alright, so the only thing that you need to do to order an RPC endpoint is go to cloud.solanavibestation.com. And once you created an account and logged in, you will see this page where you can place a new order. So we will click on place new order, and then we will select the Solana node services. They also have cloud services, and that's something that we will look at in future videos. But for now, we are going to order our own RPC endpoint. So we will click on the Solana node services, and then we can select RPC services. There are also staked RPC services, gRPC services, bundled services, but at all these things we will look at later videos. For now, we just click RPC services. And here we have the option to choose between different packages. We have the basic RPC, the ultra RPC, elite, and epic RPC. And you can see they have different rate limits, but for our testing to build our own trading bot, we will be okay with choosing the basic RPC for now. So what we will do is select the basic RPC, and here you can enter any promotion code that you have. And once you are happy with your order, you just click order. Once you checked out, you will see that you get a confirmation with your order number. And if you have any questions, you can always reach out to the official support from the Solana Vibe Station team. Now, once your order is confirmed, what you can do here on the left side is go to services, click on Solana Node Services, RPC Services. And here you will see the orders that you did and also the basic RPC that we just ordered. We can see that it is active, what we paid, the billing cycle, and when it will expire. So for more information, we can click on basic RPC, and here we will see that overview once again for our RPC. Now, we can click on connection details to get all the details that we can use in our application, like for example, the non-SSL RPC URL, the non-SSL WebSocket URL, the secure RPC URL, and the secure WebSocket URL. The next thing that we will do is check these URLs and see when we can, for example, use the RPC URL and when we can use the WebSocket URL. Because one is for doing requests and getting an answer, and one is actually for streaming to pick up events on the blockchain. When they happen, we can read into them and of course code some actions onto them. So that's what we will do now. We will take these endpoints, look at some commonly used RPC methods, test them, and eventually going to make our own trading bot. Alright, to get more information about these different RPC methods, what you can do is go to docs.solanavibestation.com, and then you can go to API docs. And there you will see that they list all the different RPC methods that we can use, both for HTTP methods and WebSocket methods. And remember, if we go back to our connection details, we have both the RPC URL and the WebSocket URL. And already here you can see that there is different methods for both. As I said, one is for streaming data and the other is often used to do a request and get an answer back. So if you look at all these methods, you will see that there is different ones. And for example, the get account info method, this we can use to return all the information associated with the account provided public key. So we can request information about an associated account by using this request and our RPC URL. Another thing that we can do is, for example, get the balance of a wallet. So as you can see here, get balance returns the Lampert's balance of an account provided pub key. So in other words, we can provide a wallet address and that method will return us the actual balance of that account. So let's try that out. We have the get balance method here. We have our RPC URL here. So in theory, we can just copy this and we can use something like Postman to actually do that request and see what we get back. So I have Postman here. I can create a new request. This is our endpoint from Solana Vibe Station. And the only thing that we need to do is provide the method body, and the method body we can also see here, and we can just copy that. So if we copy this and we go back to our Postman instance, under body, we can say this is a raw body. We are using JSON, and then we can just post that here. So the only thing that we can change is the wallet address, and we can use a wallet that I have on my own browser. So if I just quickly log in, if I would copy this wallet address here now, go back to our Postman and post the wallet address here. Of course, I need to make sure that we are sending a post, because also that is documented here under the documentation. We have to send a post request. Once post is selected and we click the send, it will return to us the actual value of that account. And as you can see here, it returns a big integer. It says 616919, and this is of course returned to us in Lamperts, but that should be the same amount as you can see here in the wallet, 0.61 Solana. And again, Lamperts is the smallest amount of Solana that can be, and of course Solana, I believe, is 1 billion Lamperts. That is why 0.61 Solana equals the Solana Lamperts that we see here. So Postman is one way of testing all these different methods. But what we can also do is using the test features within the actual live documentation. So if we go back to the Solana Vibe Station documentation under API docs and we click on the get balance method, the one that we looked at within Postman, here you can also see that there is a button saying test it. So if we click on that, a pop-up will open where we can specify all the parameters, just as what we did within Postman. And as you can see here, we will ask for the balance of a wallet. So if we now click on the send button, this will return us the balance of that wallet that we are looking at. So if you would now look at the exact same wallet as we looked within Postman, we copy the address and just change the wallet address here, click on send, you will see that it returns the exact same amount of LAMP ports as it did within Postman. It says 6169 and so on. So again, you can use Postman to test, you can use the built-in test features from the Solana Vibe Station documentation, or you can of course code your own logic. Everything works well. Now, as we saw before, there is two different types of methods. We have the HTTPS methods and we have the WebSocket methods. And at these we will look in more detail later when we start building our first tool in the next video. But again, it's good to know that the HTTP methods are often used to send a request and get back an answer, to get, for example, the balance of a wallet or to submit a transaction. And the WebSocket methods are often used to stream data to see when a certain event happens, for example, with a wallet, when it buys a token, so that we can do an action or create an action based on that event. So with knowing that, we have all the information that we need for these different types of methods, both HTTPS and WebSocket methods. We know how to test them. We know how to get a valid RPC URL that we can use to build our next applications. And with that, we are set up to jump into the next video where we will actually build our first tool, where we will get some tokens live from the Solana blockchain, fetch the pricing, and also see how we can send our own transactions to the blockchain. So all that is coming up in the next video, so make sure to subscribe so you don't miss any of the upcoming videos where we are going to build eventually our own trading bot using everything that we will learn in this series. So if you think that was interesting, subscribe to the channel, like the video, and I hope to see you in the next one.